Okay, now that we have gone through what a one-way ANOVA is, I'm going to lead you through some slides on how you would do it in SPSS. Obviously, you're not going to be able to use SPSS yourself, but at least this way you can see the process. Okay, so you're going to go to the same place that you went for a t-test. You're going to go to compare means, because that's the whole point of a one-way ANOVA. And this time you select something called one-way ANOVA. And you get a box that looks something like this. So for a one-way ANOVA, you put two variables into SPSS. One is your DV, the continuous variable. This is the one you're measuring. The other is your groups. You put it in as one variable, and then you define the conditions. So you give everybody a number based on which group they're in, such as a 1, 2, or a 3. And you create that as a separate column in SPSS. So in this screen, you put your DV, the language score, into the dependent box, and your IV, group, into the factor box. So this example is looking at whether the number of hours spent in preschool would change the language development test score of preschoolers. So they looked at 5 hours, 10 hours, and 20 hours. And they're going to see if there was a difference between the children in these groups on a score of language. So let's find out. So after you do this, don't worry about all the buttons right now. We're just going to run it. Okay? And we'll get something that looks like this. So your first box is your descriptives. You're all pretty familiar with the descriptives box. You have to report the mean, standard deviation, and N for each group. So we can see that each of our three groups had an N of 10. Now you see that the group for the 5 hours of preschool had a mean of 76.6 and a standard deviation of 11.9. For the 10-hour group, they had a mean of 85.2 and a standard deviation of 6.19. And the 20-hour group had a mean of 91.6 and a standard deviation of 3.4. So you can tell just by looking at the means, it seems like the groups that spent more time in preschool did have a higher language score. But was that difference significant? Well, for that, you need to look down at the ANOVA table that's right underneath it. Okay. So we care about the degrees of freedom column, the one that says DF, and the F and the SIG. Okay. So in this case, the degrees of freedom for between groups is 2. The degrees of freedom for within is 27. F is 8.799, and our significance, our P, is 0.001. So was there a difference between our groups? Yes. P is less than 5%. So the ANOVA table is telling us that somewhere there was a difference between our groups, but notice it doesn't tell us where. To do that, we have to do something else. We have to do something called a post hoc, which we'll see when we run through an example. So don't worry about that right now. So for right now, we can see that our groups were different from each other. So now let's talk about effect size. The effect size for an ANOVA is another Greek letter called eta, and it's eta squared. Okay, so here's the formula for that. The formula for eta squared, it's funny looking N, is between groups sums of squareds divided by the total sums of squareds. So for F, it cared about the mean squares. Remember that equation that had the big MS in it? That was mean squares. For eta, we care about something called the sums of squares. Don't worry about what those actually are. This is just how we calculate. So F was between over within. For eta, we calculate between over total. You will have to hand calculate this. SPSS will not do it for you, but it's a really easy calculation, so don't worry about it. What you do need to know is that the guidelines for how to interpret eta squared are as follows. A small is about a 0.01, so an eta squared of 0.01 is considered small. Eta squared of 0.06 is considered medium, and 0.14 or larger is considered large. Okay, so now we're going to go back to the output that we had for that example, and now we're going to calculate the effect size. Okay, so here's the output table again. Down on your ANOVA table, you should see columns for sums of squares and mean squares. Okay, so to calculate eta squared, you care about that sums of squares column. So we need to take the between group eta, or for eta we need to take the between group sums of squares, which is 1133.067, and we divide that by the total sums of squares, which is 2871.467. So if you put those numbers into a calculator and divide them, you get an eta squared of 0.39, which would be a very large effect size. So now let's actually go through an example, see if this makes more sense. Okay. In this example, participants are recruited to determine how long it takes them to assemble the able chair with various forms of instruction. So group 1 is given just text instructions. Group 2 is given text with illustrations, and group 3 is given a video. Which do you think is going to be the highest? Okay, we're going to see. So in our example, for our hypotheses, for the null hypothesis, there is no difference in assembly time across the three groups. Remember, the alternative hypothesis can't have a direction in it. All we can say is at least one group's assembly time will outperform another or be different than another. But we can't hypothesize where that group is going to be. So we go to Analyze, Compare Means, one-way ANOVA. This is where we go in SPSS. When we get that box, we put time in the dependent variable box and our group in the factor box. Since ANOVA won't tell us where the difference is, we need post-hocs. Okay? So you click the post-hocs button and you get this. Okay? Post-hoc is just Latin for after the event. That's all that it means. So when you click the post-hocs button, here's what you get. There's a whole lot of options for post-hocs. Remember how I said statisticians will sometimes argue about the best test? This applies here too. A lot of different people have developed a lot of different ways to do a post-hoc, and they will argue about which one's best. Technically, there are different tests to run based on slightly different scenarios. Some are more conservative than others. That means it's harder to find significance with them. But for the sake of this class, just select Tucky. That's what we'll do every time. Don't worry about any of the others. And leave your significance level at 5%. That's down at the bottom. Okay, then you click Continue. Now let's see our results. Here's our ANOVA table. That's not all you will see in SPSS. I just cut to the box that's the most important for you. Okay. So, was there a difference? To find that out, you look at the significance value, which is 0.001. That is less than 5%. So yes, it is significant. There was a difference between groups. So to report it, you would have to do the F, which is 7.52 or 7.53 if we round it, the degrees of freedom between, which is 2, and the degrees of freedom within, which is 102. Okay, so we know there's a difference somewhere, but we don't know where it is. So let's look at the post-hocs. This table is the post-hoc table. It looks really intimidating, but just like the correlation matrices, it's really redundant. It has the same information in a lot of different places. Okay, so let's just break it down, and it's just looking at each variable compared to, or each group compared to every other group. Okay, so first let's compare text alone with text with illustrations. We're just going to see if those two groups were different from each other. For that, we follow the roll all the way across to the significance level, which is 0.022. So were these groups different from each other? Yes. Since P is less than 5%, there was a difference between those two. The mean difference column is just literally one minus the other. So if you took the text score and the text with illustration score and subtracted them, that's the number you would get. Okay? The standard error is 2.09. Don't worry too much about that. Just worry about the P. Okay, so text and text illustrations were different. So let's compare the others now. So text and video. So now you drop down to the video row and you follow it across and you look at its P to see if text and video were different. Were they? Yes. Okay. 0.001 is less than 5%, so text and video were different. Okay. So let's look at the third. This is where it gets redundant. In the next section down, it's text with illustrations. We've already compared that to text, so we don't need to do that again. So what we need to do is compare the third set, which is video, and the text with illustrations. Okay? Were those two different? For that, we follow that row all the way across, and we see no, they were not different. But notice, just like with the correlation matrix, there are a lot of redundant numbers. So why does the sign change? You'll notice that we have here in this row we have a negative 2.229, where up above we had a positive 2.229. It's the same number, the only thing is the sign. So the only thing that's changing that difference is which group we subtracted from which other group. We're just switching their order, and that means the sign changed. Okay. So which group was the fastest and which group was the slowest? How can we tell? We can tell that text was larger than the other two groups, meaning that it took longer because they were timing them, because the sign of the difference is positive. So if you look back at that first row and text with illustrations, the difference was 5.6. So that's positive. That means text had to be bigger than text with illustrations. So we know that text is the biggest. Okay. Down where the order is reversed, when we did text with illustrations minus text, you get the same number, but it's negative. So don't worry too much about the sign. So if we look at all those signs, or you could just go back and look at the descriptives and look at the means to see the answer, text with illustrations and videos were both significantly faster than text only. You can tell that because the mean difference was positive on both of those. Okay. Video and text with illustrations were not significantly different, but you can tell by the sign that text with illustrations was bigger than video, meaning that it took more time. So video was the fastest, followed by the text with illustrations, and text only. So you can tell which one was biggest or smallest using this matrix, but I would recommend you just go up to the descriptive table and use that. So now that we have looked at all the results, how would you report the results? This is where it gets a little complicated. Okay, and we'll go through several examples. So in this one we might say we recruited 105 people and randomly assigned each to individually assemble the able chair using either text-only illustrations, text-only instructions, text with illustration instructions, or an instructional video to determine which type of instructions facilitates prompter assembly, measured in minutes. Okay, so you're telling everybody in here how many people you had, that you randomly assigned them, the groups that you assigned them to, and how you measured your results. So to report the results, first you say your overall results. Was there a difference? So we say there was a statistically significant difference between groups as determined by a one-way ANOVA. You have to say the test that you ran. And we said that it was different. So now we report it. F with the degrees of freedom 2 and 100 of 2 was equal to 7.53. P was equal to 0.001. And eta squared was 0.13 with a large effect size. So once you report eta squared, you also have to say whether it was small, medium, or large. So now we've reported the results of the ANOVA as a whole. Now we have to report the individual differences. So we might say on average the text with illustrations group, and we give its mean and standard deviation, assembled the chair significantly faster than the text only group. And now we give the mean and standard deviation, and we give the P from the post hoc table that was comparing those two groups. So we give the P that was comparing text with illustrations and text only, and that was 0.022. And then our sentence continues. It says, as did the video instruction group. If you read this without the numbers, it's like saying the video instruction group assembled the chair faster than the text only group. So we give the mean of the video instruction group and the standard deviation, and then we give the P that was comparing the video instruction group to the text only group, and that was 0.005. So you really need to make sure that you're reporting the correct P for the correct comparison, and those are from the post hoc tables. Now we've compared two of the three relationships. We have to report the third one. So we might say something like, although the video group outperformed the text with illustrations group, this 2.23 minute difference is insignificant, and you report the P that was that group. Remember, there are different ways to report the results. This is just one example. There is no one right way. In this case, you might have also said just there was no difference between the video group and the text with illustrations group, and give the P. So there's a lot more ways to do it. Okay? So now that we've reported the results, what implications would you draw? This is what would be in your discussion. You might say something like, making video instructions is more efficient. People build it better, okay, with video than with the other two. But making a video is a lot more expensive than text and text with illustrations. So should they make a video? Well, video was better than the other two, but it wasn't significantly better than the text with illustrations. So if we're weighing all of our pros and cons, our results indicate that text with illustrations might be the best way to go. Again, there are a lot of different ways to talk about it, and I will give you some more examples. So right now I just want to talk about number of groups. You can see that when we had 3 groups, we had 3 relationships to talk about, and that was a lot of information in our results section. So you have to be really careful when you are comparing groups. If we are comparing 2 groups, that's a t-test. You only have 1 comparison you have to report. When we do 3 groups, like in this example, that gives us 3 comparisons, and we have to report each of those 3 comparisons. If you switch up to 4 groups, suddenly you have 6 comparisons that you need to talk about. Okay, so each group makes more and more comparisons that you have to talk about. So if you look down at the table, it tells you how many groups you have and how many pairs that means that you would have to discuss. So can you run an ANOVA with 10 different groups? Yes, you can. But do you really want to report 45 comparisons? No. This is why I highly recommend you stick to 3 or 4 groups when you're running an ANOVA. I'm going to end this video right here, and in the next one we're actually going to run some examples in SPSS so you can see how that works.